In section 10.7, we will look at areas of circles and sectors. The area of a circle is the product of pi and the square of the radius. So we'll say A equals pi r squared. Remember, the radius is from the center of the circle to the edge. In number 1, we want to know how much more pizza is in a 12-inch diameter pizza than a 10-inch diameter pizza. Okay, well, remember, area is pi r squared. And that 2 radii make 1 diameter. So the radius of our larger pizza is 6 inches, and the radius of our smaller pizza is 5 inches. So area of our larger pizza will be pi times 6 squared, or 36 pi inches squared. And the area for our smaller pizza will be pi times 5 squared, or 25 pi inches squared. Now let's subtract them to find out how much more pizza is in the 12-inch than the 10-inch. So we'll take 36 pi inches squared minus 25 pi inches squared. We get 11 pi inches squared, which is about 35 inches squared more. Okay. Number 2 says a circular archery target has a 2-foot diameter. It is yellow except for a red bullseye at the center with a 6-inch diameter. Find the area of the yellow region, round to the nearest tenth. So the target's diameter is in feet, whereas our red bullseye's diameter is inches. So let's convert the targets. So the target's diameter is 2 feet, or 24 inches, making the radius 12 inches. So let's first find the area of the whole target. So area of the target, pi times the radius squared. So for the whole target, our area is 144 pi inches squared. Then the area for the red bullseye will be pi times its radius, which is 3. Because remember, the diameter is 6, so then the radius is 3. So area for the red bullseye will be 9 pi inches squared. If we want to find the area of just the yellow region, we need to subtract the area of the target and the area of the red bullseye, since the yellow regions, right now, it's being included in that total area. So take 144 pi inches squared minus 9 pi inches squared. We get 135 pi inches squared, which is about 424 inches squared. So that's the area of the yellow ring in our bullseye. Sector of a circle is the region bounded by the arc of the circle and 2 radii. The area of a sector of a circle is the product of the ratio measure of arc AB divided by 360 and the area of the circle. So referring to our circle on the right, if I wanted to find the area of that shaded region, which is the sector, I would take the measure of arc AB divided by 360 times pi r squared. In number 3, we want to find the area of sector ZOM. We know that arc ZM is 72 degrees and our radius is 20 centimeters. So to find the area, we will take the measure of our arc, so 72, divided by 360 times pi times our radius squared. So simplifying, we have 72 divided by 360 times 400 pi, and multiplying through and reducing, we get 80 pi centimeters squared. And if we wanted to round this to nearest tenth, we would get 251.3 centimeters squared for our area. Number 4, we want to find the area of sector AOB, and our radius is 8 inches. So for area, we will take measure of our arc, so 120, divided by 360 times pi times our radius squared, so 8 squared. Simplifying, we have 120 divided by 360 times 64 pi multiplying, we get 21.3 pi inches squared. And rounding this to the nearest tenth, it's about 66.9 inches squared. So that's the area of the sector, our shaded region there. The segment of a circle is a part of a circle bounded by an arc and a chord. So in the first circle, that is the shaded region on the right. That's our segment of a circle. If we want to find the area of the segment, we first find the area of the sector, then subtract the area of a triangle, and we have area of the segment. In number 5, we want to find the area of the shaded segment. We're going to round our answer to the nearest tenth. Okay, so to do that, we first need to find the area of the whole sector. So area of our sector, now we know our arc is 90 degrees because we have a right angle in the central angle, and the measure of arc AB is the same as the measure of angle AOB. So we will take 90 divided by 360 times pi times our radius, which is 10, and then we're going to square that. So area for the sector is 90 divided by 360 times 100 pi, and to the nearest tenth, it's about 78.5 inches squared. So that's the area of the entire sector. We next need to find the area of the triangle. Remember, area of a triangle is 1/2 base times height. Well, my base is 10, and my height is the perpendicular segment that is connecting the one vertex to my base. So, and actually it's the radius as well, so it's also 10. So we're going to take 1/2 times 10 times 10, base times height. So area of our triangle is 1/2 of 100, or 50 inches squared. So to find the area of the shaded region, so area of shaded will be 78.5 minus 50, or 28.5 inches squared. That's the area of just that small shaded segment. And finally, number 6. It says a circle has a radius of 12 centimeters. Find the area of the smaller segment determined by a 60-degree arc. round to nearest tenth. Okay, so let's draw in the center of our circle. So we have a radius of 12. And we'll go ahead and we'll draw our angle. So it's telling us that it's a 60-degree arc. This is also a radius, so it will be 12. We first need to find the area of the sector. So that will be 60 divided by 360 times pi times our radius squared, so 12 squared. So area of our sector, 360 divided by 360 times 144 pi. To the nearest tenth, it's about 75.4 centimeters squared. Now we need to find the area of our triangle. Okay, well, we need to draw in our triangle. So it's saying eventually we want to find the area of this shaded segment. Okay. Well, I know my angle at the top is 60 degrees. If I draw in my perpendicular line segment, which is my height, that cuts that 60 into 30. This angle's 60. So I have a 30, 60, 90-degree triangle where my hypotenuse is 12, meaning the shorter side is 6. So my height in my triangle is 6 square root 3 centimeters. So to find area of the triangle, take 1/2 times the base is 12 times 6 square root 3 is my height. So that's 36 square root 3, or about 62.4 centimeters squared. And lastly, to find the area of the shaded region, we will take 75.4 minus 62.4 to get 13.0 centimeters squared.